Would a solution containing 50 grams of potassium nitrate per 100 grams of water, water is 1 gram per 1 mil. You can add to that as a note, 1 gram equals 1 milliliter. So when we say 100 grams of water, it's equal to 100 milliliters of water. So will a solution containing 50 grams of potassium nitrate per 100 mils of water be unsaturated, saturated, or supersaturated at 40 degrees Celsius? So potassium nitrate, we're looking at this steep line here. We're looking at 40 degrees Celsius. So 40 degrees Celsius is right here. So we're looking right here on our graph. If it contains 50 grams, so 50 grams is here. So 50 grams falls below this line. What this line represents is a saturated solution. So if you have 60, it looks like 64 grams of potassium nitrate at 40 degrees Celsius, that would be a saturated solution. So if we only have 50 grams in 100 milliliters of water at 40 degrees Celsius, it's below the line, that would be an unsaturated solution. So for D, unsaturated, because at 40 degrees Celsius, 65 grams of potassium nitrate, KNO3, can be dissolved in 100 grams or milliliters of water, and 50 grams is less than 65 grams. So that means we can remember our definitions of what unsaturated, saturated, and supersaturated solutions are. If you can continue to have more solute dissolve in the solvent, it's considered unsaturated. So this is the saturation point. We're below that. We can continue to add more. It's an unsaturated solution. At what temperature would a solution containing 50 grams of potassium chloride in 100 grams of water be saturated? So here we're going to be looking for the temperature. KCl, potassium chloride, is this one. So we're looking at this line here. And we have 50 grams. So we're going to find 50 grams. See where that meets this KCl line right here. And then follow that back to find what temperature. So follow that down, 76 probably, just over halfway between. So 76 degrees. At 76 degrees Celsius, a solution containing 50 grams of potassium chloride in 100 grams of water would be saturated. Would a solution containing 120 grams of potassium nitrate per 200 milliliters of water be unsaturated, saturated, or supersaturated at 30 degrees Celsius? So now we have a new dynamic here. 200 milliliters of water. Our graph is per 100 milliliters of water. So we can't compare these numbers with these numbers because our units aren't the same, which means we have to change them before we can use our solubility curve. If this is 120 grams per 200 milliliters, we can divide and find out how many grams per 100 milliliters. To get from 200 milliliters to 100 milliliters, divide by 2. So to get from how many grams of potassium nitrate you can have in 100, you have to also divide this by 2. So this would be equal to only 60 grams per 100 milliliters. So we want to write that out first. So would a solution containing 60 grams per 100 milliliters, we can kind of add that in here, be unsaturated, saturated, or supersaturated at 30 degrees Celsius. So we can look here. We're looking at potassium nitrate again. This line, I believe, let me check. Yeah, potassium nitrate. So 60 grams per 100 milliliters, and we're looking at 30 degrees Celsius. So 30 degrees, follow that up to where it hits potassium nitrate's line, follow that over. So at 30 degrees, we can only have about 46 grams of potassium nitrate dissolved in 100 milliliters of water, which means that if we're looking at, this is our saturation point, we have 60, we're way up here, 60 grams dissolved in 100 mils at 30. So now we have the case where it's over the line. If it's above the line, that means we have more solute dissolved than what there should be at that temperature of a saturated solution, which means we have a super saturated solution. So just to recap, the line, on the line is a saturated solution, below the line is unsaturated, and above the line is saturated. So here, it's a super saturated solution, so super saturated because at 30 degrees Celsius, normally only 46 grams, whoops, not degrees, grams per 100 milliliters of water would dissolve. Okay, last question. What amount of potassium chlorite in grams will be precipitated if a saturated solution containing 100 grams of water cools from 70 degrees Celsius to 5 degrees Celsius? So when we have a saturated solution cooling, it forms a supersaturated solution, and any disturbance, because it's very fragile, will cause the excess that's dissolved to fall out of solution and return back to a solid state. So you'll see that happen when we do the lab on this when I get back from the West Coast. So what we need to look at here is how many grams of solute of potassium chlorate is dissolved in water at 70 and at 5 to compare them. So we're looking at potassium chlorate, so this one, we're following this line. At 70, we follow this up. In a saturated solution, which means we're looking at the line, it can hold about 32 grams, and we're going from 70 all the way down to 5. So 5 would be about here, can probably hold, it's just under halfway, let's say 4 grams. So at 70 degrees Celsius, we can have 32 grams dissolved in a saturated solution. And if we're cooling it down all the way to 5 degrees Celsius, it can only hold 4 grams. So we had 32, it can only hold 4 if it dissolves. We're going to subtract. So 32 minus 4 equals 28 grams would precipitate or fall out of solution. Okay, so that's all of the examples. We've seen a variety of different styles of questions that I could give you about solubility curves. The next page is practice questions, all very similar to those ones. You're going to be using, you can use this one. Some of them are different substances, so you'll need to use the solubility curve on the back as well. Work on these for practice. The answers are posted in EDSBay if you want to check your work. And the last thing that you're going to do is I've given you some example data of how to build your own solubility curve. Normally I would do this as a lab, but we won't have time this year, or if we do, it'll be after I get back from the break, so we're going to just give it a shot to practice using Excel. It's really important in chemistry that you know how to make a graph in Excel, so we're going to practice using some fake data about dissolving potassium nitrate in water. So you've got some data here. Here's your temperatures and your solubilities. So these are going to be your X values and your Y values. I'll post another video showing you how to make a graph in Excel, and you'll be able to follow those instructions if you don't already know how to do it. Create your graph. You're going to print it off, have your table and your graph on the same page, and then answer a couple short questions about that data. This page you can remove from the staple it to your printed off Excel graph with your name on it, and you can hand it in next class. And that will also be for homework. If you have any questions, I'll do my best to answer them via Edsby message or email in the evenings when I have a spare minute, and I will do my best to get back to you guys. Hope this worked out all right, and let me know what you guys think.